Hi, and welcome everybody to this webinar. My name is Barak Budo. I'm the DevRel for Scribe Security. I've been a long-time programmer and a relatively short-time DevRel, and we have a very distinguished guest with us this evening. Say hello, or I would say hello for you, for Tzachi Zorenstein, who's the head of software supply chain security at Checkmarx. Prior to Checkmarx, Tzachi was the co-founder and CEO at Dustico, a SaaS-based solution that detects malicious attacks and backdoors in open source software supply chains. That startup was later acquired by Checkmarx in August of 21. So, how are you, Tzachi?
I'm great, Brock. Thank you for inviting me here, and it's great. And I'm really excited and waiting for our talk.
Awesome. As the title of this webinar says, we're going to be talking about lesser known vulnerabilities in GitHub. To those of our viewers who don't know, and I'm guessing there's not a lot of you out there, GitHub is one of the more popular SCM platforms around. SCM meaning source code management systems, or source management, not just source code. Currently, or at least as of last June, it reported over 83 million developers and more than 200 million repositories. That's a lot of repositories, including at least 28 million public repositories. That's, not counting all the private things, the things that you don't know about, can't see. GitHub is also widely used to build and distribute software using their own tools, their own CI/CD platform, actions, workflows. I would like to start by asking Tzachi, how can we understand or help us understand what is the scope of software supply chain vulnerabilities, or how would you define actually your job as the head of software supply chain security at Checkmarx? Are you in charge of all software supply chain everywhere on the planet, or is it
In the
something more,
galaxy, in the galaxy.
more localized?
So actually, it's a growing field. So software supply chain is a huge issue, and it's gaining a lot of traction. We've witnessed last year SolarWinds, and then we witnessed Log4j, and numerous attacks since then, including the latest Circle CI. And we understand that we need to better secure our software supply chain assets. And there are numerous organizations out there working towards that goal, including OpenSSF. And basically, the entire community just is working together. And one of the things that I think will be crucial for that success is the kind of cooperation we're doing right here, Barak, because basically I do think that the only way we can move forward is if everybody will work together. Of course, nobody can do everything. My focus is basically being more focused about the open source packages.
Mm-hmm.
And basically, I'm not a developer, I'm a cyber guy. So basically, I just ask myself, okay, you've seen all those great open source projects and people are using them all the time. Who's vetting the code? Again, coming from a more suspicious background and tracking and hunting down cyber criminals and advanced attackers, I thought to myself, is there a way for the bad guys to exploit the trust in this system and try to poison our software supply chain? So there are many moving parts to
Mm-hmm.
that problem. There is, as you said, not just the open source packages, but local code, GitHub actions, CI/CD. There are multiple angles to that attack. Basically, what me and my team is doing is tracking attackers poisoning open source packages and stopping them. And part of what we're doing is research about ways they can actually hijack and modify a legitimate package. And one of those techniques I'll be presenting later today.
So, so the follow-up question, because you said, a lot, and poisoning packages can be a lot of things. What was the catalyst for starting to look at GitHub specifically? What got you started looking into GitHub as a source of potential problem? Not just for the vulnerability we're going to talk about today, but just in general.
So basically, GitHub contains a large percentage of the open source package in the world, which are stored on GitHub in multiple ways. So thinking from the attacker point of view, if I would like to attack a package, where are the package placed? And most of the packages are in GitHub. So a lot of time we take the attacker mindset and then we just follow what would an attacker do. And basically, it's interesting because the attack vector that we found was actually used by attacker earlier this year a couple of times. So we're just following the attackers and stopping them where we can.
Well, since we teased I think, our viewers enough, let's talk about what you found. A couple of months ago, you reported a vulnerability called repo jacking. Uh, because I'm not sure all of our viewers are familiar with the term or the vulnerability or the attack, why don't you tell us about it?
Okay, so let me share a couple of slides I've prepared. And this is, to be honest, one of the coolest vulnerabilities we ever found. Anybody can exploit that. You don't need to write any code or shell code or buffer overflow. It is more of a design issue that we found. Let me just share my screen, Brock, and tell me if you can see my presentation.
Yep, I can see
Okay.
it. What is repo
So
jacking?
what is repo jacking? Great. So basically, as you said, repo jacking is a technique you can use to do a software supply chain attack, and it's quite trivial to exploit. And the end of this attack actually allows me to inject remote code into a lot of different projects and high import projects from companies like Google, GitHub, Facebook, Kubernetes, basically a lot of them. So there are a lot of vulnerabilities out there, but most of them are closed and I don't care. And I guess that this is a bit different because this vulnerability can affect our audience. And basically we are seeing attacker abusing this vulnerability. Just earlier this year, we saw a PHP package with more than 2.5 million installation compromised and added malicious code using this repo jacking technique. And this is just one of the cases that we have seen. So this vulnerability is interesting because it's been exploited in the wild. And let's try to understand maybe about who is vulnerable and how can I protect myself. So basically, there are two conditions to be susceptible for repo jacking. The first one is your code needs to be directly referenced from a GitHub repository, meaning you're using a code that is source is GitHub. And we said, like before, a lot of the code out there is actually based from GitHub. And the other condition, which is a bit more interesting, is that the owner of that repository have changed or deleted their username in the past. Let me show you a couple of examples. So first of all, we talked about my code needs to be referenced from a GitHub repository. What do I mean? As you mentioned before, we are familiar with version control system like GitHub, GitLab, Bitbucket, and package managers. So the difference is in many cases that we use code, we not automatically go into GitHub. In many cases, we go into package managers. Package managers like NPM for JavaScript and for Dart and PyPy for Python. And in those cases, I'm not going directly to the source code. I'm actually going, I would say, like an application store and take my code from there. But there are languages, and Go is an example of those languages, that actually you take the code directly from the source. It's not just Go, it's Go and Swift and PHP. And in those languages, you don't go and install a package from a package manager. Actually, you can see in the screen that I'm showing you, you actually go directly to GitHub, directly to a specific repo, a specific project, and take the code from there. Basically, in this design of Go, PHP, and Swift, the attacker doesn't need to touch the package, he needs to touch the repo. So from the attacker point of view, seeing and understanding that, we thought to ourselves, how would an attacker would feel? How could an attacker could take control of that URL? Because basically, if he's taking control of that URL, is basically handing you the code he wants. So we started our investigation. A lot of those codes is in GitHub. Is there a way we can hijack a link, hijack a URL? And then we discovered something really interesting. We discovered that GitHub allows people to change their GitHub usernames, and your GitHub username is part of your URL. So whenever you change your GitHub username, and that's allowed, your URL will change. You will still get a warning sign, something like this. Do you really want to change your username? And people change their username, although they have this like a bit terrifying message. Yeah, I'm gonna change my username, that's okay. And when you change your username, you don't think that anything has changed. Because basically what happens, in order to preserve functionality, GitHub will set up an automatic redirect. For example, Barak, suppose I'm using github.com, Barak, your great project, and you change your name to Barak1. In my code, when I'm actually referencing your old username, everything will still work because I'm going to the old username and automatically getting a redirected a new username. So everything is working as expected. You don't think that nothing has changed. I don't know, you think to yourself, I don't know why GitHub gave me this warning. Everything is still working, but, and there's always a but, the reason that they allow the old username to continue to exist is that existing references will continue without breaking, but the old username is now free. So although it's working, it is possible for another attacker or another developer to claim that old username. Once I claim that old username, people are actually referencing me. And now there is no redirect. People are actually thinking that they always use the old username, get redirected. Now it's not redirected. They don't see what's happening. And now I can serve them my own malicious code. So basically the mixture of a rename, which actually opens the code that I'm actually serving, or people getting me for a hijack, or what we call repo jacking, because I can I can steal your repo account. This method is actually used to hijack old references and to serve malware, or I would say malicious packages. So you're probably thinking to yourself, I've never changed my username. Is that a real problem or not? So just looking at the Go ecosystem, this is the number of packages that we found today that they are susceptible for repo jacking. And if you can see, there are a lot of very popular projects out there that their original developer at one point decided to change his username. So they are possible targets for an attacker. And I know that I'm talking about Go, but again, this isn't specific for Go. We found the same with Swift and PHP. So basically, language that they decide that there will be no package manager, there will be no Python or NPM, they will actually go directly to the source control system. If you are able to take control on the source control system, in this case GitHub, you can directly interfere with what you're doing. And this is exactly what I actually talked about and we saw earlier this year. So what we actually saw is there was a package, and it was quite popular, to be honest. At one point, the GitHub account closed this account or could have renamed this account. So although the URL was still active, it was open for anybody else to grab it. An attacker actually realized that, registered the same username, and just create a new repo. He cloned the old repo, add some malicious stuff into it, and he was able quite easily to affect a lot of different people. So basically, with repo jacking, you don't need to write any fancy shellcode or anything like that. You need to find somebody who have changed his email account, changes GitHub account, and that's quite easy. You just follow the redirect, and you can just register his old GitHub account and then try to take over his old repo name. Now, there are protections in place because GitHub realized that, and they decided to add a protection against this use case. But their protection actually applies only in specific cases. they actually says, okay, we have a popular repository namespace retirement. In this case, we will not allow the combination of a username and a very popular repo name, but this protection is only applied to specific projects. And the metric when GitHub decides if that repo will be protected or not is basically if that project had more than 100 clones in the week leading to the rename. That's cool. The problem is, for me as a developer going to a repo, I don't see this metric. So there is no visible way to see, am I protected or not? So I'm using a repo. It could have been renamed at some point, and then it would be up. It will be up for repo jacking, but I don't know if the GitHub protection is actually in place or not. And we think that we should get more visibility. Am I protected or not against repo jacking? Not only that, their popular repository namespace retirement mechanism, their protection mechanism, I wouldn't say it's bulletproof like everything in open source, because my team actually found two vulnerabilities that allow me to bypass this protection. And to be honest, another researcher just found another vulnerability in that. So even if it is protected, it's not bulletproof. So when there is a rename, there is a possibility of somebody hijack the old username. So what do we say to our listeners, to our audience? Okay, I understand rename could lead to something bad. How can I detect and prevent this? GitHub is offering protection, but it's not bulletproof. It's not automatic. Basically, I would say, and that's an easy mitigation, reference the updated package URLs to avoid the risk. If Barak changes username to Barak1, and I want to use one of Barak1's repos, I'll actually use the new URL. I wouldn't just wait for the redirect to help me. I would actually do that proactively to minimize the risk. The question is, how do I know if one of the packages I'm using actually had its developer name change? Can I see that? And we actually developed an open source tool for the community called Changejacking. And basically, and I'm going to show you like a short video. It's called the Changejacker. It monitors package that can be taken over and alerts the ecosystem. And basically, what happens is that you can quite easily run this tool as part of your CI/CD or once in a lifetime. It's checking the open source package that you are using. I'm going to change and add a repo that is actually susceptible for repo jacking, the Falcon Plus. Running this script again, I can see, I'm using a package, which is, in this case, a Go package, which could be a PHP, or it could be a Swift, that is susceptible for repo jacking, and I better like change the URL to the correct URL, so I won't be vulnerable to repo jacking attacks. So this is basically one of the things around GitHub that, although we reported and we've seen exploited in the wild this year a couple of times, I'm not sure that the entire audience knows about that, and that's why I'm so appreciative of you letting me coming and just talking about that. So open source software are powerful tools, use them carefully. The impact is not clear as it might seem. Again, there is a warning when you change your GitHub account, but I'm not sure people are aware of the risk there. And renaming your repository might cause havoc. So that's basically my repo jacking story for this session.
Well, it was definitely very engaging. I would like just to add that the incident which you mentioned is linked in the show notes. So if our viewers are interested in the case study or exactly what happened, just find the link and you'll get to the article talking all about it.
A funny anecdote about that. Basically, the guy who poisoned the package actually added code that says, when the package is running, please take the AWS keys and send them to me. When it was discovered, by the way, I think he panicked a little, because after a couple of days, he went on Medium and he actually says, guys, it's me. I'm a ethical hacker.
Really?
Although I stole your sensitive keys, I never meant to use them. I'm sorry. Please forgive me. And the funny thing is, while we were investigating and reporting on that, he actually gave us a like in LinkedIn in Medium for our description of his attack.
Okay.
So
There's no bad publicity.
liked by attackers, right?
Yeah.
So, and again, since that we actually found more vulnerabilities in there, and I think that we need to consider this mechanism of rename and redirect not safe until GitHub will actually show us what is protected or not. Because right now you can guess maybe it's protected, maybe it's not. You're not gonna go and try and hack all of those repositories to find out for yourself. So
Well, earlier, because we talked a little bit before we got to this webinar, we mentioned how GitHub, as a rule, as a whole, is not built for security. It was actually created to enable sharing and easier developer work. So if you build something to enable easier sharing, putting security and stopgaps and stop measures and permissions on top of it, there's bound to be gaps. You actually mentioned some problems with the UI or user experience actually on GitHub, where green colors that denote safety are used where they're not supposed to. How easy it is to basically hijack the trust system or the pretend trust system for developers, as in, yes, of course, I'm working with this big company and my code is in this big repository and I have lots of stars and lots of comments. I am awesome, but it's all a lie.
yeah, so I think that GitHub, and we mentioned before, is a place to store codes, which is great. But I think GitHub also has a social angle to it. It's people stars people and get recognition and writes their own profile and things like that. So people actually using GitHub also as some kind of a reputation system. So when they're taking code from somebody, they want to make sure on GitHub this guy is legit and active and verified and all of that. So I have a different lecture, not for this WebEx, but I hope you invite me again,
Sure.
calling 5 easy ways to still develop a reputation. And
Ooh.
then we show that a lot of the metrics that are actually being shown on GitHub, like activity, number of contributors, stars, even the place that you work here are not necessarily as verified as you think they are. So I really don't like the concept of developers should do a better job, because developers are working very hard, and we need to make sure that we do everything that we can to help them, make them work easier. So again, we are releasing the tools, we are helping the community, but I think only if the community will work together, we will be able to tackle those problems and show that what we are seeing is actually legit, and stopping attackers, because attackers are actually abusing this. We are seeing in the latest couple of months attacker actually abusing this reputation system, building fake developer accounts in order to gain more impact to their attacks. I actually had one attack, I think last month, that was so successful that the repo hosting that attack was a trending project on GitHub.
Wow.
Yeah, and it was very nice, because people started asking him, okay, you're trying to push us to install this package, is it safe or not? And he basically gave a great answer, which I now have on a t-shirt upstairs. He said, guys, it's not a virus, it's open source.
It is a great answer, and yeah, that's a good T-shirt,
That's a
definitely.
good issue. Yeah. So
Yeah,
so we are seeing an all around attack around GitHub and packages and the reputation system. We don't think the problem will go away. We think the attacks will only worsen, and we are seeing that like every other week. And it's important for the companies working in that, releasing tools. And I really like your GitKat tools, which you mentioned later, but we are using that internally because we really like the output is giving us, and it's actually part of our automatic checks that we run like every week. And so giving back to the community is the only way that we can secure the open source ecosystem.
Yeah, and letting people know, because not everybody is obsessively reading all the security news
There's a
like
lot.
probably both of us do. So letting people know, keeping them informed about the potential problems, and just opening their eyes to how insecure things are as opposed to how secure they seem is an important step in the process. And speaking of that, I would like to share another vulnerability that our head developer, Mikey Strauss, discovered last year, actually very early last year. We reported this in March. It's called cache poisoning. Now, a lot of our viewers are probably using GitHub because that was the how we described this webinar. So if you're using GitHub to build and push your software, you are probably familiar with the workflow system in which you can run things sequentially or in parallel. Essentially, you're putting together a series of steps that describe some sort of action, a bunch of tests, compilation, whatever it is you're describing, it's eventually done however you describe it. Now, each workflow is individual. In order to protect the process, GitHub has defined that each of these workflows must be a completely different environment. However, sometimes products of one workflow are needed to be used in another, sometimes the resources, sometimes the output. So there has to be some sort of mechanism in place to enable that sharing. A cache is one of those mechanisms. Let's say you are coding in JavaScript and you're using NPM. If you're doing this on your own computer, you're probably downloading all those packages and putting them in node modules. But if you're doing this in GitHub and a workflow, well, you can't really, I mean, you could probably, but it wouldn't be realistic to expect each workflow to download all the packages necessary for the compilation and testing of your code and doing it each and every time. When the first time you're doing npmi or npm install, it could take, depending on the size of all your dependencies, it could take minutes. So it's not really logical to do that for each individual workflow. So the workaround is to have a cache. Essentially, if there are a lot of packages or a lot of libraries, any other sort of thing needed across workflows, GitHub allows you to put it all in a cache. Now, obviously, you basically request in your workflow, give me access to my cache. If it's not there or if it's different than what you expect, you download it for the first time. At the end of that particular workflow, you save it to the cache. And every other time you need the cache, you will ask for the cache. It's there. You get it. Everything is great. Except if in a particular workflow, something happens, and for whatever reason, that cache is different than what you expect. Let's say there's a dependency confusion, a very common thing in the NPM sphere. Somebody simply changed or upped the number of a particular version, and suddenly, when you ask the cache, there's a difference. You get the new cache with the slightly bigger number on that particular package. But the beautiful thing here is that once that cache is saved, it is now updated, it is now saved, every other workflow, every other repository, every other time you are calling for the cache, you'll get the poison one. You'll get the slightly different one. And unless and until there's a need for a new cache to be created, every call for that cache will get the bad one. That's why it's such a persistent form of attack and such an insidious one, because in most cases, there's no way for anybody to know that the cache that's being used in the workflow is poison, is different than what you expect. There's a link to the article discussing this discovery in the show notes. I encourage you to go and check it out. It's really, really cool and interesting. Because it's interesting, we thought really hard about how we can advise people to protect themselves against it. Obviously, we told GitHub, but we got the expected answer that sharing cache between workflows is not a bug, it's a feature. There's nothing they want to do about changing that because it's a really, really needed feature. There's no reason to work around it. If they told us if you're worried about people getting into your workflow or changing your cache or your code, well, basically use our security system, our protections, permissions. Just make sure that the workflow that is writing to the cache is as protected as it could be. That is a great answer, and it's always true that you should uh, make sure that the workflow that is able to write things or change things in your environment or your repository is as protected as possible in terms of permissions, but it doesn't actually solve the problem. We do have a suggestion that is also using open source or our tool to cryptographically sign um, a repository or a cache and then check or verify the signature, but it's not ironclad and it's not easy. We do, however, have an open source tool which Tzachi mentioned earlier. It's called GitGat, which is I think a cool name. It evaluates your GitHub security as a whole and allows you to basically look at either your organization or your private GitHub account and see where there are gaps. It gives you a report which you can constantly run over and over again. You can even automate the running of the report. It basically looks at four major groups of potential security problems in your GitHub: access control, permissions, branch protection, and modification tracking. And the modification tracking is the really cool and interesting part because, admittedly, GitGat as an outside tool can't really prevent anybody from accessing anything. But it will allow you to put certain repositories or libraries or basically anything that you want to protect with a specific list of users that are allowed to access that particular repository or library. And again, we can't stop anybody from accessing it if they have the ability, like if they're an admin in your organization. But anybody who accesses something that they're not supposed to will appear in your report. So at the very least, you know something was wrong. This is an example of the report, or just at least just the beginning of the report. I encourage you to check out this really cool tool. The link to GitGat is in the show notes, like I said, and we also wrote a really comprehensive course for the Linux Foundation about GitGat because essentially when we wrote it, we found out that we're not just writing a course about GitGat, we're actually writing a course about GitHub security. Because in order to understand what GitGat does, you need to understand what GitHub security options are and how to use them. So, the course is free, like most Linux Foundation courses. I encourage you to check them out. Again, the link to the course is in the show notes. Now that I've talked about my open source tool and Zahi discussed his open source tool, and we told you that GitHub was not built for security, and you should beware and keep your eyes open on what you're clicking or using or incorporating into your code or your repository. Zahi, what else can you tell us about how to beware and be careful? You did say it's not a virus, it's open source, but open source, as we know, is extremely highly used everywhere. So other than basically looking, which again could tell you lies, what other thing can you do to make sure that you're not falling victim to phishing or typo squatting or dependency confusion or any other of a myriad of other possible vulnerabilities that could mean that whatever safe code you thought you were building, you were just building a Trojan horse for other people to basically abuse your users?
So for me, just before we'll move on, I'm not a developer, and my background is not developer, but again, protecting complex system is a thing that we've done again and again in different places inside the network, inside other places. And to hear the problem that you described, the attack, for me, it's like what we used to call elevation of privileges and lateral movement.
Mhm.
Basing, okay, if nothing bad will ever happen, that's okay. But if something bad will happen, you can take that access and do like lateral movement across different workloads, and you can get more permissions. So the concept of don't let bad stuff happen in the first place and you're protected hasn't proved itself very effective against
Mhm.
attacker. This is why we are seeing now that we are talking about zero trust. Not all workloads should share the same cache, right?
Mm-hmm.
Maybe there are different classification. So as I said, the platform was built by developer for developers, but I think that we need to evolve as way the attackers will evolve and will use those design I wouldn't say flaws, but those design decisions to get an access in one workflow, poison the cache, and just then move to other workloads, other parts of your backend and server. So for me, it's really alarming to see that there is no really separation. Once you're in, you're in. And we are
Mm-hmm.
actually seeing that more and more because like in the latest breaches that we have seen, and I'm talking about the Circle CI, and I'm talking about source codes being leaked from many different organizations.
Mm-hmm.
We are seeing that attackers are focusing their effort on developers because they understand that developers has a lot of access, and those access isn't necessarily monitored, signed, verified as it should. So I think that we will just see more and more on those attacks. I would suggest that, and again, what we are doing right now is that we are publishing a lot of our reports and what we are seeing with the open source ecosystem. So I would actually do encourage people to go to Medium or our LinkedIn or Twitter to get the latest on those reports. We are working together with the OpenSSF to get some kind of a deny list. So for me, that's the basic. One of the things that I'm fighting is people think that if I'm using what we call the vulnerability scanner to scan code, it will detect malicious packages. I did an interesting, and I can understand why, right? Vulnerable, malicious, it's the same, but sadly, it's not true. I've just done an experiment a couple of weeks ago. I've scanned 9,000 malicious packages that were vetted and reported against one of the best open source vulnerability database out there. Can you guess how many results from the 9,000 I get this package isn't legit?
Probably less than 1,000.
Zero.
It's less than 1,000.
It's less than 1,000. Because basically, right now, we are tracking vulnerabilities. We are not tracking malicious.
Mm-hmm.
So we are publishing all those on different portals and Checkmarks as a portal there. And we are giving this, reporting those packages back to the package managers and to GitHub on a daily basis. So for me, from the developers standpoint, please be careful when you're doing the package name because typo squatting is quite popular lately.
Mm-hmm. Yep.
And even if it's a popular package, we are seeing now attackers targeting popular packages, which we've not seen before.
Makes sense.
So the field is, please be vigilant. Please check the tools. We have a couple of open source tools out there in our website and your website to check is this package legit or not. And we are working very hard to get those tools better automated because I don't think developers need more information. They just need a verdict. So most of the tools right now give you a lot of information, but the developer can look at the code and decide he doesn't want to look at the code. He just wants to get his job done. So we are working what Microsoft is called tier 3 to build a deny list for malicious packages. We are actually building some kind of an AV for open source packages. So we will do all the hard work, and you just like can know that the packages that you are using are safe. Vulnerable is one thing. Sadly, malicious doesn't fall right now under this category. Maybe it will change in the future. And please make sure that you have the right tools in place or right open source tools, right portals and tools. And we have work to do as an ecosystem. It's on us.
Definitely. I would like to add, because it's recently in the news, that the increasing usage of basically AI or chatbots to write code, check code, is not doing anybody any favors. Beyond the fact that a lot of the AIs out there are being trained on open source repositories, and there's no guarantee that those repositories were written safely to begin with, There's the problem that, again, because of developers' tendency to trust big corporations, big names, if an AI gave them a piece of code, they tend to think it's safe, it's secure. It might really, really not be. It might even be written really bad. It could work. I'm not saying it's not. It doesn't work, but it might be written only in such a way that it would enable, bad actors to quite easily get in there and do something bad. I just saw recently that OpenAI has tried really, really hard to add ethical limits on ChatGPT, but in exactly the same place in which I saw the report. And I was like, "Yay! It's not going to write any more, phishing campaigns and basically malware that will require you to pay Ethereum to open your account." On the very same place, there's responses, and the very first one was, "Yeah, I was able to convince him to let me write a reminder for my brother to pay me 20 Ethereum." So all it makes is basically makes the bad guys more creative to get the tools they need to write their code. They don't even need to be coders anymore, like you mentioned earlier, because people are building the tools for them to write the code that will hurt us. So
Yes.
being aware, being vigilant, opening your eyes, being careful of permissions, of what you do with what code is extremely important, no matter where you host your code or how you compile it, or where you save your images or your final products, where you ask people to download them from. All of it is hackable and basically not inherently safe. Of course, there are ways to try and make things safer, but you need to work at it. It doesn't come naturally. And any big company that tells you, "We got it, trust us, it's fine, everything is safe," don't. Just don't. It doesn't look like we have too many questions. I guess we were really convincing in explaining what we wanted to explain. So, Tafi, before we end this session, do you have anything you would like to add to our viewers?
No, thank you for your time, guys. I think that it's up to us and you to educate the other people, developers around you. I guess that people tuning in to this WebEx are what we call early adopters and thought leaders who understand the problems. So I really want to thank you for your time, not listening to me, but also I think that basically we are all ambassadors of there is a problem. We need to work together to fix that. So thank you specifically, Barak, for having me on. I hope I wasn't too bad and that we learned something in this session. And feel free, guys, to reach out either our social or look at our Medium blog post because there is a lot of stuff going on. And we're always happy to share and to give knowledge and to help others. Working together to keep the ecosystem safe is basically our motto, my team's motto. And also have a t-shirt
Awesome.
for that.
Awesome. I'm pretty sure that at least one of the questions will probably going to be, where can we get those t-shirts? So you better find a way to make them public. And I would really like to thank Zahi for his time and his awesome explanation and the fact that they found this vulnerability in the first place. Because if they hadn't, it would still be going on. It probably still is in some way, but I'm sure that his team will find out all the variables to plug those holes. So again, Zahi, thank you very, very much. And thank you to our viewers. We'll see you next month. Bye.
Bye, guys.